All right, today we're talking about something that's way more than just a small step forward for developer platforms. We're talking about agentic platform engineering. And this isn't just about giving developers shinier tools. No, this is about giving your entire infrastructure its very own AI copilot, one that can actually think for itself. So let's get into it.
So, just picture this for a second. Instead of you getting that dreaded alert at 3 a.m., your platform spots the problem, figures out the root cause, and then opens a pull request with the fix all before you've even had your morning coffee. This isn't some far-off science fiction dream. It's the real promise of what an agentic platform can do.
And this slide is the perfect way to think about this whole shift. You know, most of us are still driving that manual car on the left. Our platforms give us a road to drive on, sure, but we're the ones gripping the steering wheel, navigating, and pulling over to fix every flat tire. The agentic model on the right, that's the self-driving car. We just tell it where we want to go, like deploy this new feature and make sure it's highly available, and it handles the rest.
So why do we need this massive shift in the first place? Well, it's because even the absolute best golden paths that we build today are just riddled with potholes. They need constant care and feeding, endless updates, and a human to jump in the second something goes wrong. They are, by their very nature, completely reactive.
This table just lays it all out crystal clear. We're moving away from things that have to be started by a human and towards things that are proactive and started by an agent. I mean, just look at error handling. The old way is an alert screaming that something is on fire. The new way is a quiet notification telling you that something was on fire, but it's already been put out. That's a total game changer.
Okay, so how does this magic actually happen? How does a platform go from just being a box of tools to, well, a thinking, reasoning partner? It really all comes down to a simple but super powerful operational cycle.
And here it is. This is the brain and the central nervous system of the entire agentic platform. We call it the Sense, Think, Act loop. It's this constant cycle that lets the platform see what's going on, decide on the smartest response, and then actually do something about it. Let's break that down a little more.
First, it's senses. And it's not just passively monitoring data. It's using an LLM to actually understand the context behind the logs and metrics. Then it thinks. This is where it maps out a complex, multi-step plan, just like a senior engineer would. And finally, it acts. The agent gets its own identity, its own permissions, so it can push code, kick off a pipeline, or spin up new resources. It actually has hands to carry out its own plans.
Now, that think part we just talked about, the reasoning engine, it's not a one-size-fits-all kind of deal. See, different jobs require different kinds of thinking, and that's where all these different AI agent frameworks come into the picture.
And just look at how specialized these brains can get. If you want a self-healing system, you'd probably use something like LangGraph. Its cyclical model is perfect because it lets an agent try a fix, check if it worked, and if not, try something else. For security, Crew AI can build a whole team of agents, where maybe a security officer agent has to approve a deployment. And for those really risky operations, AutoGen can actually chat with a human engineer to get the green light before it acts.
Okay, this all sounds incredibly cool, but let's get down to brass tacks. What does this actually mean for the business? What's the real, measurable payoff for going down this road? Well, the numbers, they're pretty eye-popping.
First up, and this one is huge, we're seeing a 40% faster developer onboarding time. And that's because the platform itself is automating that whole painful setup process that used to take weeks of manual work.
And this chart really puts that number into perspective. We're talking about taking an onboarding process that's typically 3 weeks or more and squashing it down to just 1 week. The agent is handling everything, provisioning tools, granting access, so new hires are contributing on day 1, not day 21.
Next up, a 30% reduction in cognitive load for your developers. Just think about all the brainpower your team burns every single day just wrestling with tool chains, troubleshooting weird environment issues, and trying to navigate a complex infrastructure. Agentic platforms just take all that toil off their plate.
And finally, here's the number that gets every CFO to sit up and pay attention. Up to a 15% reduction in your overall cloud spend. This comes from agents that are working 24/7 to autonomously optimize resources, right-size instances, and kill idle infrastructure way more efficiently than any human team ever could.
And look, this isn't just theory. Just look at Google Cloud's Autopilot for GKE. They use these exact same agentic principles to automatically manage their Kubernetes clusters, and they cut wasteful over-provisioning by a massive 40%. This stuff works in the real world.
So when you put all these pieces together, you see these incredible benefits across the entire organization. You get faster onboarding and less cognitive load, which leads directly to a 25% bump in developer productivity. You throw the cloud savings on top of that, and the business case is just undeniable.
Now, I know exactly what a lot of you are probably thinking right now. Handing over the keys to our production kingdom to an AI? That sounds, well, it sounds terrifying. And you know what? You're right to be cautious. So how do we get all this power without risking a total catastrophe?
The people building these systems absolutely get it. This quote hits the nail on the head. You can't just unleash a powerful AI and cross your fingers. The whole secret is building a system with rock-solid, non-negotiable safety boundaries from the very beginning.
The solution is this concept called bounded autonomy. And let's switch up our analogy. Think of the AI agent as a highly skilled airline pilot. It knows how to fly the plane, but it still has to obey every single command and rule that comes from air traffic control. And in our world, air traffic control is a powerful policy engine. This control plane has three absolutely essential layers. First, you've got a policy engine, something like OPA, that enforces hard-coded rules the agent literally cannot break. Second, a confidence score. If the agent comes up with a plan but isn't, say, 95% sure it's the right move, it has to stop and ask a human for approval. And finally, the ultimate safety net, a big red kill switch that can instantly revoke all of the agent's permissions. And here's the really brilliant part. These guardrails don't just block bad ideas, they're also teachers. When that policy engine denies a request, the agent doesn't just give up. It takes that denial as feedback, it thinks about why its plan failed, and then it comes up with a new plan that actually follows the rules. It learns to be a better pilot over time.
So when you put it all together, this incredible autonomous power with these rock-solid safety features, you end up with a totally new way of thinking about infrastructure and about what it means to be an engineer. This right here is the great shift. For decades, automation meant writing these incredibly detailed, step-by-step scripts telling a machine exactly how to do something. That era is coming to an end. The future is all about telling our new Silicon teammate what we want to achieve and then trusting it to figure out the best way to get there. And that's the real question I want to leave you with. When your team is finally free from that endless grind of manual fixes, environment setups, and managing cloud costs, what new innovations are you going to build? What incredible problems will you solve when your platform is no longer just working for you, but working with you?